Hi, my name is John Paul Raj, and my mission in life is to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 2 of data capture. So if you haven't already seen part 1, I'm going to link that video in the description box below. Please go and take a look at it. Let's get started. Before we go on, I think I must just clarify one thing. Technology is not everything. I'm going to repeat that again. Technology is not everything. However cool the feature is, even something as cool as data capture, I really feel this is one of the coolest features of the TI Nspire. But when you're working on your IA or your EE, it must be your research question. That is the most important thing. Your RQ must determine whether or not you need to use technology, to what extent you must use technology, how judiciously you're going to use technology. Don't just use features at random. Sometimes when I show these features to my students and students just go accordingly in a very religious way, oh, we have to find the regression line like I showed it in the earlier video. Don't just find the regression equation because, you did it in a certain other investigation. What you do in your investigation is determined by the RQ, the research question. Don't copy and paste procedures. We found an equation using the regression technique, so we have to use the regression technique and find equation in every case. That's not nice. That's not cool. That's not what an investigation should be. Your investigation should be led and guided by the research question. So don't follow procedures religiously like that. Okay. So think about what the research question is and let that drive the use of technology and use technology wisely. That being said, let's jump straight into a calculator. This is the CAS version that I'm going to be using. I always encourage using the CAS for explorations and simulations. You should also do that. Okay. This is the lists and spreadsheet page, and this page kind of becomes central to every data capture feature because you're capturing data, and normally what will happen is that you'll be capturing coordinates, or maybe you'll be capturing an X coordinate with a certain other measurement like area, and you'll be comparing this data. So this becomes kind of a central thing, the list and spreadsheet page, where you'll be capturing the data, right? And you can use data capture for not just for IAs and Es, and that means not just for IB students. You can also use it for your IGCSE class to learn something in trigonometry. And to demonstrate that, the first thing that I'm going to do is going to talk about something from trigonometry. Okay, so to save up on time, I've already laid this unit circle down. This is a unit circle. The equation of the circle is here. X squared plus y squared is equal to 1. Now that you have seen the circle, I'm just going to hide the circle so that it's out of the way. And as you can see, that there's a point there on the circle, which is making an angle 45 degrees with the positive x-axis, and this point is on the circle, and the point is free to move along the circle. And as this point moves along the circumference of the circle, you can see that its coordinates are changing, but at the same time the angle that it makes with the x-axis also changes. So if you want to study the relationship between the y coordinate and the angle at that particular instant, at any given instant, at every position, what is the relationship between the y coordinate and the angle that it makes with the x-axis, that can be done using data capture. Now I skipped this part because this is more on data capture, not on geometry, but you can easily go on the geometry tab here, explore the different things that you can do on geometry. There are different shapes you can draw, circles and triangles, and a lot of things that you can explore. But that's one of the first things before you must even get into the data capture mode, meaning you have to set up what you intend to do. So in this case, it was a trigonometry lesson or an exploration in trigonometry. So we want a unit circle, so I've drawn a circle. Maybe it's something else that you're looking for. So the setup involves some kind of a geometry tools that you might need to explore and do it on your own, okay? I'm going to skip that because I want to do this on data capture. So what we're going to do right now is that we're going to see the relationship between the y coordinate and the angle that it makes. All right, so on the list and spreadsheet page, which I already have here, I'm going to call this list, let's just call it list 1. List 1. And this one will be list 2. And what we're going to do is that on list 1, we're going to capture all the y coordinates of the point as it moves along the circle. And along list 2, we're going to go and capture all the angles, the corresponding angles at each of those positions. For that particular y value, 0.728, the angle is 46.8. So we are going to go and capture all the angular measurements on list 2. All right. So before we do that, the first thing to do is that make those angles or that coordinates or that measures, make it a variable. That's the first thing. All right. So I'm going to go and right click on the y coordinate. I'm going to say store, and that's going to be called y. All right. Nothing original, nothing fancy. And this case, I'm just going to right click on the angle, right click there, store. I'm going to call this A for angle and hit enter. So A is for angle, and that's the y coordinate, and that's become bold. And that's the first thing you should do. So if it's some other measurement like area or perimeter, you are trying to compare, study the relationship between the perimeter and maybe the circumference of a circle or the diameter of a circle, then that's a measurement, right? So you can actually calculate that, and that's what you make it a variable, assign it as a variable. That's the first thing you should do before you capture that. Now on the list and spreadsheet page, since we want the y coordinates here, I'm going to go to menu, data, data capture, but this time automatic, and the variable we are trying to capture is y. So we hit enter, and automatically, the current position, if you go and see, the current y coordinate is already entered there. And when we do the same thing for the angle, you go to menu, data, data capture, and I'm going to say automatic. And here I want to capture all the A's, corresponding A's for that value of y. I hit enter, and I see that 46.8 has been registered there, which was the angle here. Now we're ready to capture the data. As you can see, it's all blank. But what we're going to do in addition to this is that simultaneously what we'll do is that we are going to go and add another graph page, okay? And this is another graph page. I'm just going to hit escape. My intention is that as the data is captured, as the y values from this point is captured here, for the y values and the angles are captured, this data is going to then be plotted here like a scatter plot. All right, that's my intention. So let's see what we're going to do. We're going to arrange this axis first, because we know some of us know what this exploration is going to be, right? So we are going to go and set it up somewhere here, and yeah, this is good enough, but let me just make sure that it is just right. So window settings, I'm going to go and make my X minimum can be negative 10 degrees, and X max needs to be at least 360 degrees. So we're going to make it 400, and X scale, we can keep it as, what should we keep it? Let's keep it 30 degrees, and the minimum and maximum, let's keep it negative 1.5 and 1.5. And this one can be 1 or 0.5. All right, with that, I think our graph page is also ready. What we're going to do now is that I'm going to go and say menu and graph entry edit. I'm going to call for a scatter plot, because it's going to give me a scattered arrangement of all the data that's collected. And the data that's going to come here is going to come from this list and spreadsheet page. Here, list 1 was the y coordinates, okay? And along list 2, we are going to get all the angles. We want to study the angles along the x-axis, and the y coordinates at that point moving along the circle to be the y here, the y value here, okay? So this is going to be my list 2, okay? List 2, because that's the angle, all right, that's coming from there. And here we are going to get the data from list 1. So I hope you are clear with the arrangement so far. List 1 is containing all my y coordinates, y values. Right now it's blank. Oh, there's only one point here because that was the only point that was captured, as you can see here. But list 1 is going to contain all the y values. List 2 is going to contain all the angles. And what we have set up here is a scatter plot. So the moment all the data is captured here, you're going to go and you're going to get to see all the data as it is captured, okay? Actually, if you even split the screens, but it's going to be very crowded, you can even see it live, all right? So now we're ready. I think this page is ready. This page is also ready. So let's move the pointer around, okay? So as you move the pointer around, the data is going to be captured, should be captured. And the more smooth you are, if you go around, back up, and the more smooth you are, the more slow you are, as many data as possible can be captured. So we are going to stop here, and we're going to go and take a look at our table. And as you can see, it's already populated enough, okay? More than enough. And when you go and take a look at the graph page, guess what? You see a certain pattern. And this is a nice way to investigate, okay? So basically what's happening is the y values against the angle for every angle value is giving you a nice, interesting shape. And then the students can explore, what is this shape? Because this is a scatter plot. This is not joined. These are all points. And you can see there's a gap here. That means, if you go and make more data points to be captured, the more you capture, all those data sets are not just captured on the list and spreadsheet page, but here it's already plotted. You already have the scatter plot, and it's the shape of the sine wave. And to confirm that, you can go and even enter the sine function. You can just say, okay, you want to see the sine function, right? So sine of x, you can say that, and it's in blue color. But if you want to just see how well it coincides, I'm just going to change the color of my function that I entered. let's make it my favorite magenta color. And you can see that the sign function is in magenta, but the blue is actually coming from this list of values, and it's a perfect match. Two things. One, this is a nice investigation to help students see, even at an IGCSE level, that, how we can use this data capture to investigate what is the relationship, what then is the y coordinate of a point on the unit circle, what is it going to generate, and then they can say, oh yeah, that looks like the sine wave, and then you can say that on the unit circle, the y values are corresponding to the sine value of the angle that it makes with the x-axis. That's a good investigation. But if you notice anywhere, I did not use regression. And this is what I meant when I said, don't use these techniques religiously without thinking. Do we really need to have that regression equation? No. The purpose of this investigation was something else. Let the purpose, the research question, the why, let that drive your investigation. So use data capture wisely and judiciously, not religiously like a procedural method. Okay, so we have to use regression equation. Don't do that. Okay, so anyway, I hope this was helpful. I just also want to point out that this is not just trigonometry where you can use data capture. You can also use the same feature of data capture in something like this, which is more IB. You might have seen a very similar question there where there's a rectangle, a triangle, some geometrical object, some polygon inscribed within a shape. This is a parabola, and so it's an inverted parabola, and with 2 points on the curve and the other 2 points on the x-axis. And this investigation, the question, the RQ is to find the relationship between the area and the x-coordinate. The area is the calculation, length times width. So this time, area, the calculation is being captured. All right, it's not just x and y coordinates. In the earlier case, we took the y coordinate. This time, we're taking the x coordinate of this rectangle. So when we go to the list and spreadsheet, what we have on the first list is x plot, which is the x coordinate of that point that's going to be captured here. And the second list is a plot, which is the area of that rectangle corresponding to that position where the x coordinate was 3.92. Okay, and not only have we created a list and spreadsheet page, but a corresponding graph page. Here's where we're going to have a scatter plot. That point that's already plotted there, you can see there, that's already that 1.3.92 and 514, whatever that value is of the area, 514.23. So that's what that point is there. But once we have captured all the data here, automatically a scatter plot of all the data, okay? All the y values are going to be the area values, because that's what we want to compare, the area with the x values. So the x values are going to go on the x-axis, okay? So let's go and do that. We'll move the point around the curve. And the more points you, the more smoothly you move this point, the many more data points you'll get, a smoother scatter plot you'll get. Okay, so let's just do this a couple of times. Once you're happy with that, let's go and take a look at our points. They will not make any difference to you because, yeah, what are we going to do with that, right? So here's the scatter plot, and that's the area of the rectangle, okay, along the y-axis, and that's the data corresponding to that. Okay, it's coming from the second column B. Now, to verify that, we can go and take a look at our rectangle. We know that the area of a rectangle is length times width. The length is going to be 2x. Okay, so this is the origin. So the x value is that, so it's going to be 2x. And the width is going to be the y value because that's seated on the curve, right? So the y value is 81 minus x squared. So I've already entered that somewhere. So when we go to the function, we're just going to say to x times f1x, because f1 is already registered there in that original diagram. When I hit enter, you get a curve in black. So I'm just going to change the color so that it will stand out for us. I'm going to change that color to my favorite magenta color. And then my favorite magenta color, can you see that it actually matches that very nicely? Very nicely it matches. So that's the area 2x times f1x, because f1 was that already defined here. Okay, and what we can then also do is that we can actually find the maxima or the maximum value of this area of the rectangle, which is given by this function, because they will both coincide. So we can go and take a look at the maximum value of that function, lower bound, upper bound. It's supposedly to happen at x is equal to 5.2. X equals 5.2, you should get the maximum value. And that can then be checked, verified here. At x equals 5.2, what's going to happen? So you can actually go and take a look at your readings. That's 8. That's the value of x, right? And that's 7. What do we have? Yeah, 5.1, 561, 515. And as you can see at 5.1, it's 561. And then anything below 5 is like 540. And then above 591 is 544. See, that is the investigation. That is the investing. That's trying to find the relationship between the x and the y values. And so you know, if the students want, they can, you know, go back and, you know, try and see, okay, we said, what was that? 5.2. They can even go back to this point and try and see what will happen at 5.2. Can we get it at 5.2, 5.21, 5. Yeah. 5.21 is the closest I can get it. But let me see at 5. Come on. 5.2. Yeah, there you go. That's the best I can do. You can do better probably. But at x equals 5.21, the area is 561.18. And that's probably the same thing. Can you see that 561? That's investigation. That is how we use data capture. Not just using it religiously. Please don't get me wrong. I'm saying that so many times. But use technology judiciously is all I'm saying. So we've seen two different examples, one for IGCSE students as well as one that can be used in an IB exploration. There are many other places you could have used data capture. I would like to hear from you where you've used, okay? Then there's one more example I want to quickly show you. This is approximating pi, the value of pi, using the Archimedes' method, okay? You've got a polygon inside the circle, outside this is a square. This is a four-sided polygon right now. And when you keep increasing the number of sides of the square, the data gets automatically captured and plot. This is a data statistics page, by the way. It's not the normal graph page. And it's a stacked plot of the two perimeters. Okay, the red referring to the red rectangle, the square in this case, and the blue showing you the blue dots showing you the blue square. And as you keep increasing n, here we're using the slider. You know, can you see that? The plots, the dots get plotted here, and they both are coming to the same value. So this is something on approximating limits. You can talk about limits in this case. All I'm trying to say is that data capture can be used in different contexts. And according to the context, you must choose to use the correct app. So don't make a religious format. Okay, we need to do regression. In part 1, we used a regression equation to find that curve that best fits those points. But in none of these examples that we saw today, we use the regression. So use it wisely. And please let me know how you've used it in your class, in your investigations, whether you're an IGCSE student or whether you're an IB student. I would love to hear from you. I'm going to see you all in the next video.